Hey guys, welcome to our channel. In today's video, we're gonna be exploring one of the most common challenges in Flutter, which is managing the synchronous state. Yes, almost every app needs to read and write data, either locally or externally. And if this is not managed well, then trust me, the consequences can be severe because it gives you a poor user experience, performance issue, increased bugs and errors, difficulty in maintenance and scalability issue. So without further ado, let's get started. For fetching data, we already have future provider and stream provider from the Riverpad package, which does a very good job for managing the state and decoupling the logic from the UI. This also provides us with a better API compared to the built-in future builder and stream builder. So because of that, we'll be focusing on the async operation that returns void or returns nothing, like for example writing and updating data, sign in and sign out. Alright, so for those of you already familiar with this controller pattern, using state notifiers of class, I understand your frustration is because we're on the same boat. The problem here is that we reach a synchronous function, we found ourselves needing to create separate controller class. Let's take our chat app for instance. We need one controller for the sign-in method, another for creating a group chat, another for sending a message, and so on and so forth. These requirements keeps adding up, making the process tedious and cluttered. And if you've noticed, all of the controllers have the same functionality and share the same logic, which is kind of repetitive. Especially when writing a unit test, you are testing the same logic over and over, which is not only time consuming, but also makes it inefficient. So what we're gonna do is to extract the logic behind this awesome but a bullshit repetitive controller class and create a single class that we can reuse to make it an awesome and fantastic class, which reduces our workload significantly by writing once and reuse everywhere. To save time, I've already written the code and will just simply walk you through it. For those of you unfamiliar with this and are curious or want to learn about it, you can check my video on async state management in Flutter with State Notifier Provider. I'll add the link in the description below. As you can see, the structure and the codes are still the same. The only difference is instead of passing the dependency like this, we are passing the function as a parameter here, and then calling the function here as usual. So to use this controller, we are watching its state like this, listening to its error like this, and then trigger the execute method like this. From this point in time, we already did a significant improvement because we no longer need to create another controller for the other synchronous operations we have. However, these providers are still kind of repetitive because we need to define this in all of the widgets and screens where we need to show a loading indicator. So what we're gonna do is to create a consumer widget that holds this listen and watch method. Alright, let's create the widget. Name it whatever you want, but for this demo, I will name it a synchronous widget. Let's pass the child. Let's define the listener here. This is the function where we need to handle the incoming error, but we don't want to handle here because every operations may have its own way of handling errors. Maybe some would show a snack bar and some would show an alert dialog. So we'll be passing as a parameter. Alright, alright. And then let's watch the state here. Okay, that's it. However, if we use this widget, let's say we use it in our home screen, we can now remove this. Let's wrap this with the widget that we have just created. Alright, the problem here is how can we access the state of the controller? And how can we trigger the execute method of the controller? So what we're gonna do is to make them available as a parameter from this child. So we're gonna be transforming this into a function widget and then pass the state as well as the execute method as a parameter. Let's go ahead and do that. We also wanna pass the callback function here in the constructor, where we can define the function that will be passed here. Alright. Alright, so we have converted the child to a function widget, passing the state, and then passing the execute method. And we also defined here the callback function that will be passed here in the execute method. Now here in the widget, we can now have access to this state. And then we now can pass to this loading parameter, so that this primary button will show loading indicator when the controller is in a loading state. And then we now can call this execute method inside this onPress method. Just like that. And here in the callback function, let's call the API that will be called inside the execute method. Okay, there you go. Let's try this out. Okay, it's now working. Okay, as you can see, it's now working as expected. However, if you also wanna use this widget to this here in the delete account button, Okay, let's try this out. Okay, let's try this. This is the problem. We can see that these two buttons are sharing the same state. And once the error is thrown, the listener will show an error dialog twice because two instances are listening to a single controller. That is why if we close this, we still have this another error dialog. So why is this? Why does this controller not create an instance of each widget that is listening to it? The reason for that is because of this provider. When a class is wrapped with a provider, it singletonizes the class. It creates a reference, preventing for its reinstantiation. So how can we fix it? How can we say to this provider that we need an instance for each listener? Well, what we can do is to add the .family modifier to this provider and then pass a unique ID from each listener. So let's go ahead and do that. Okay, so here, let's create an ID here. I'm using the current date here to make sure of its uniqueness and then pass the ID here. Like this, just like that. And then let's refresh it. I mean restart. Okay. Okay, moment of truth. Oh, it doesn't seem like it was addressed. Um, okay, so I think we need to define the ID from here. So we need to pass the ID. Uh, we don't want to. We don't want to define the ID here. So let's pass it. Fine. ID. Let's pass it here. Let's test this out. All right. Okay. Okay. As you can see. Okay. All right. Each button now creates an instance of the controller, and they are no longer sharing the same state. So, all right. Last thing that we need to address is how can we pass a parameter to this execute method when it's needed. So to give you an example, let's take a look at the example of this group chat screen. So here in the group chat screen, we can see this send chat function, which is empty at the moment, and we can verify that it's not working here. See, because this is an empty. So now we need to implement the controller that we have just created here. So let's wrap this with the asynchronous widget. Okay. All right, so here let's call the execute, and then let's call the API here, send group message. As you can see, the message and the images are required here as a parameter, but this message and images are available here. They are not available from here. So how can we make this available here so that we can pass it to this function? So what we need to do is we need to pass this message and images to this execute method. So let's go back to this asynchronous widget and make this a type T so that we can pass any type of parameter that we need. And then pass an optional parameter of type T to this execute method. And then from this execute method, we will pass the type T parameter to this callback function. Alright, so let's do that. Alright, let's just update this. And we don't need to pass any parameter here because this doesn't need a parameter. We can just simply assign a null as a parameter. And then let's make this type of dynamic like that. Let's do the same here. Alright, so if you don't need to pass a parameter, you can just simply pass a null value here. So let's go back to the group chat screen. Alright. Now the problem again here is we need to pass a to parameter. But this execute method can only cater a single parameter. So what we're gonna do is to encapsulate these two parameters into a single class. So let's define a chat param here. I define this class here for simplicity, but in your case, you need to define this in your domain layer folder. So now let's use it here. Okay. Let's give this a type of chat param like that. And then we can tap on the param.message, param.images, and let's check here if param not null and user not null. All right. Okay. Let's now restart this up and let's see if this works. Oops, why? What's happening? Oops, what's happening? It works, but send group message. I did not wait this. Oops, we made an error. We made a typo. This execute. child. This one. We made a typo here. Future. Okay. Like that. This needs to be a future. Yeah. Alright. Hmm. Oh, we are getting, but yeah, we forgot. We forgot this state is loading. All right, right. Let's test it. Okay, it's now working. There you go. That is how to pass a parameter, and all right. We now have a single reusable widget that manages our asynchronous task. This change saves us significant amount of time because we no longer need to define separate controller class for each asynchronous operation. You can store these two files inside your common widgets folder, or you can create an internal package for them, just as I have done with mine. If you identify any drawbacks or limitations to this approach that I might have missed, or if you have suggestions for further improvements, please share your thoughts on the comment section below, and I'm eager to explore your feedback. And if you found this video helpful, please give me a thumbs up, share, and subscribe. Thank you.